Okay, welcome to grade 11 college math. We're in the probability unit, unit 5, and this is lesson 4, interpreting information involving probability. And our goal for this lesson is to interpret statistics in the media. So, probability and statistics are presented through the media in a variety of different contexts. Statistics is the collection and analysis of data. Okay, well, statistics are collected from real life events and studies. Like probability, statistics help predict results of future events. So, based on statistics, we can make predictions and guess what will happen in the future. Here are some examples of statistics. We might have opinion polls, you could have census data. Census data is like how many people are in a population, or what background do they have, where are they living, how many people live in their household, and it helps governments, such as Canada, know how many people live in the country and what types of demographics they meet. So we got opinion polls, census data, weather reports, maybe gambling odds, very popular, you know that. Sports reports, so maybe how good a pitcher is, or how a winning percentage a quarterback has. So it could be team data. Right? Player data. All right. So we have many different things. There could be stock market predictions based on statistics, things such as that. Okay, so here's an example of someone's favorite music stations. A local radio station surveyed 200 students from one high school to determine their favorite type of music. The results are shown in the table. We have the type of music: rock, rap, and country, and the percentage of students: 45, 35, and 20, and that does add up to 100. So we're asked to then express each percent as a decimal and as a fraction in lowest terms. Okay, so we have the rock crowd. Well, they are 45%. So they would be 45 out of 100 people, or 0.45. How do we get this into a percentage? Well, you could use your ABC button. Because they want it in a fraction lowest terms. So 45 over 100 reduces to, well, 5 goes into both. 5 goes into both. 5 goes into 45 9 times. 5 goes into 100 20 times. And I can't think of a common factor that goes into both of those. So we can't reduce the 9 and the 20. So it is 9/20. All right, rap. Well, rap, we're told that 35% of the students like it. So that's 35 over 100. Okay, which can reduce. We know 5 goes into both. 5 goes into 35 7 times and into 120 times. So what does this end up being? Well, it's 0.35. So you can work different ways here. You can work straight to this, or we can go this way, then this way. It works either way. Okay, now what about our country music fans? Our 20%, which is 20 over 100. We know that 5 goes into both of those, so we would have 4 over 4 over 20. We can actually go further than that and break it down to 1/5, which is also 0.20. All right, so just working with some fractions here. Again, use your ABC button if that helps you reduce fractions. Okay, if there were 4,000 high school students in the city, how many of them would you expect to like each type of music? So this is where the use of statistics can help us in predicting. So if we have our rock fans at 45% of 4,000, we are going to say, well, 0.45 times 4,000 will give us, again, take a moment to do that on your calculator, and we have 1,800 people liking rock. All right, and in rap, we continue. We say, okay, well, 35% equals 35 out of 100. Sorry, I was redoing the one up here. Okay, 35% of 4,000 people equals 0.35, okay, times 4,000. Again, we get out our calculators. And we get 1,400 people liking rap. All right, so now the country, we have 20% of 4,000. So that's 0.2 times 4,000. Well, it's going to be something with an 8. So 2 times 4, that's going to be 800. Now, quickly looking at these three numbers should add up to 4,000, and they would. So this and this would be 3,200 plus 800. So that's one way we can predict. Now, one last question to do with this. Is it possible that the poll might be inaccurate? What factors could influence the responses? Well, certainly, this is only a prediction, so yes. Influencing factors could include. So just think of all the possible things. So here's some examples. So maybe the type of music played by station doing the survey. Okay, we would call this perhaps a bias, because if it's a rock station, they might, you know, be influenced to emphasize the rock was most popular. Okay? Well, popular music, um, popular music teachers, maybe that has an influence, the teachers. What about just a tendency um, to like certain music according to region? Like, okay, let's just, maybe be a bit stereotypical, but let's say in the city, you like rock and rap more, and then when you get outside the city, perhaps you're liking country and rock more, so you're getting a bit of a crossover of rock. So depending where this school is, that would influence it for sure. Okay, lots of other things that might be happening. Maybe the popularity of overall genre that in that era. So if this is the 80s, I think, you know, um, rock is more popular. It's the 90s and then rap's more popular. You were seeing now a resurgence of some country music. Anyways, you get the point. All right, let's move on to the next one, page. So, what about examples of statistics and probability? All students in a high school were surveyed about 2 sports. The results are shown in the graph. All right, so whether they like basketball or football, and what was the frequency that students voted for these. So there's 4 choices actually, but only 2 sports. There's basketball only, there's football only, there's liking both, or there's liking neither. So express each as a decimal. So one thing we need to figure out is what was the total. So quickly, what was the total surveyed? Well, we had 190, 340, 565, and 100. This is important because this sets our denominator number. So 190 plus 340 plus 565 plus 100 equals 1,195. Okay, so let's take each example. So basketball. Well, we were told that 190 people like basketball out of the 1,195 surveyed. We punch that into our calculator, and they want these as a decimal. So we are going to 190 divided by 1,195, and we have 0.015899. So we're going to round it to 2 decimal places, 1/6. All right, now let's do football. So we have 340 people that say they like football out of 1,195. And we'll do that math quickly. 340 divided by 1,195 equals, again, 0.2845. So we're going to be rounding that to 0.28. Okay. Now let's do both. Now the group of people that like both and the group of people that like neither. So the group of people that like both was the most combined. Okay, and the group that liked neither was 100. All right, so 565 divided by 1,195 equals 0.47. And finally, 100 divided by 1,195 equals 0.08. Now, it didn't ask us to, but you could quickly turn these into percentages by multiplying them by 100 to make them into a percent. So we can do that next. What is the probability that a student chosen from a at random likes basketball but not football? So that goes right to our first example right here, this column. So we would say that the probability, remember we're using this idea from last note, basketball only. Okay, so there was 190 people that like basketball only out of 1,195, and that gave us 0.16 times that by 100, and we're going to shift that decimal place, and we're going to get 16% probability. Okay, so just grab any student out of that school and just grab them in the hallway and say, there's a 16% chance that they will be a basketball fan first. What is the probability that a student chosen at random likes either basketball or football, but not both? So we're looking for the combination of they like basketball or football, but not both. It's a little different than saying just getting the combined both. So what happens is it's the probability of basketball or football. So that is the combination of the two. So again, we go up here and we had 190 people liking basketball, 340 liking football. So 190 plus 340, okay, now combined in this bracket, all over the total possible. So these two numbers add up to 530. Okay, so it's 530 divided by 1195. We have 44%, so 0.44, or as we say, 44% chance that the student will either likes basketball or football, but not both. All right, and then finally, okay, what is the probability that a student chosen at random likes basketball or football or both? Wow, that's going to take up a lot of the students because only 100 students didn't like any of it. So we have probability of basketball, football, and both. Well, that's going to be 190 plus 340 plus 565 all over 1,195. And so that all adds up to, punching that into our calculator, okay, we have 1,095. Okay, so 1,095 divided by 1195 is almost everyone. So almost all the students like some sort of form of sports at the school. So 92%. There we go. Okay, so that's one way. Those are some ways to interpret and come up with your own statistics. There we go. So you have a worksheet labeled 5.2.4 worksheet, and you have some practice questions in your textbook that you will be doing for homework. All right, thanks for watching, and see you next time.